Hi everyone. What we're doing today is we're continuing with the solar system and galaxy. We're looking at astronomy, the final lesson of astronomy, where we're looking at the benefits and dangers of space exploration. We're looking at what is space, what is a solar system, what is a galaxy, and we're then trying to link it all together to try and figure out how they all relate to each other. Okay, and you probably have a few ideas before we start this lesson. Okay. And what I'd like you to do is look at these learning intentions here. We have the solar system, the galaxy, space, the relationships, and the benefits and hazards. It'd be a good idea if you sat down and wrote down what you know about these topics before we start. Okay? So, one question I would always ask here before we start is which is bigger? Is it a solar system or is it a galaxy? Okay? So, we kind of throw these words around the place all the time, and often we kind of use the wrong terms. Okay, so we have the universe, the galaxy, and the solar system. Which is bigger? Okay, so clearly here in this one here, if we're talking about the galaxy and the solar system, this is a galaxy. Okay, this is a solar system. It's just called the solar system here, but normally if it's other solar systems we're talking about, they usually have a name. Okay, so this is our solar system. And really, what's the difference? Well, this here, this solar system, is basically just like a unit or a part of this much, much bigger system here, which is a galaxy. Okay? One of the defining features of a solar system, coming from the word solar, is that they have a star. Okay? So when we define a solar system, what we would say is that we have a star and we have all the celestial bodies that orbit it. Think about what celestial bodies orbit a star. In this picture, clearly we have the planets, the 8 planets. We've also got things like a dwarf planet, like Pluto. We have got things like asteroids and comets, and we have got meteoroids all orbiting this star. So a solar system, to define it once more, we say that it is a star and all the celestial bodies that orbit it. Okay? So I think that one's pretty easy to remember. Just remember it as from the word solar, star, and celestial bodies that orbit it. That leads us on then to the galaxy. What is a galaxy? Well, when you look at this picture here, you see lots and lots of little lights. And what do the lights represent? They represent stars. So there are millions and millions of stars here in a single galaxy. Okay, and these millions of stars are all held together in this galaxy by gravity. So it has this sort of circular pattern, almost oval structure in pattern, because of gravity. So the gravity is really important here, and gravity is something we'll look at again in second year. But gravity is what's keeping all of these objects in on their orbit. Um, and I suppose for the time being, just imagine, like, how is the Earth staying on its own orbit as well? Imagine you have a string and you have a ball on the string, and you start spinning the string around the place, and in other words, creating a circular pattern. Now imagine a space where there is no objects to slow it down. There's no air causing friction to slow down the planet. So the planet continues on its orbit. Okay, it's not slowing down. And that's the same reason that you have all of these planets here in orbit here on their same orbit, is because they're not slowing down, because it's almost like a string and a ball. The ball represents the planet. The ball is continuing its own path. So if we're defining a galaxy anyways, we'll look at a galaxy. We say all these different lights represent the stars, and all these stars are held together by gravity. Okay, so that's how we define a galaxy. System of stars held together by gravity. Now, in order from biggest to smallest, we'd say the universe is everything. So everything at all in our environment around us is the universe. Okay, and underneath that, then we have we're talking about thousands of galaxies. So there's thousands of galaxies that make up this universe. And then we also have solar systems. So we have millions and millions and millions of solar systems. So there's many, unimaginable amount of these out there. Okay, our solar system is just called the solar system, but any solar system we discover is called, we give it a name. Now, you might question, is there actually other solar systems out there? Well, we know there are other solar systems out there based on this guy's work here. His name is Edwin Hubble. You might have heard of the Hubble telescope. The Hubble telescope tells us that showed us really that um, by looking at the space and making different measurements, we were able to see that there's other stars in the galaxy and that there are other celestial bodies orbiting these particular stars. So we knew this to be a solar system. Okay? Now, we have covered an awful lot the last few weeks, and we have looked here at a number of different kinds of celestial bodies. What I want to now look at is how does all of this fit together? So if we look here, as we mentioned earlier, we have the universe, which is everything. Now we will be talking about the Big Bang and everything in second year, and we look at how the universe began. But thousands of galaxies make up this universe. We're talking about billions, order of billions of solar systems, and then we have the celestial bodies themselves and space. At this stage, I want you to pause the video. I want you to look here at try to remember the different types of celestial bodies we have encountered. Okay, so to list them off, what have we seen? We've seen asteroids, meteoroids, meteorites, meteors themselves. We have seen stars. We have seen moons, planets. We have seen space. We've talked about space debris. We have talked about solar systems and galaxies. All of those will be considered celestial bodies. Okay, so when we talk about the universe here and the galaxies, we could take a little branch off this to include our galaxy. So our galaxy here is one of thousands of galaxies out there that are known, and we call this the Milky Way galaxy. So if we follow this along, we follow our own solar system. So our solar system, if it's considered to be a solar system, it must, remember, contain a star. So we have a star and it's called the sun. It must also contain celestial objects, or bodies rather, that orbit it. So the things that orbit here are the 8 planets. Okay, remember our rhyme here to remember the 8 planets? We've got other things that orbit it that are not mentioned here, like for example a dwarf planet. We've got meteoroids that are just orbiting around space. We've got the asteroid belt, which is between Mars and Jupiter, which is orbiting our solar system, or orbiting our star. We've got the comets, which are found at Kuiper's belt beyond Neptune, okay, which again are orbiting our star. We've got the star, which is called the sun. We've got moons out there, which orbit planets, but because planets orbit the star, which is the sun, they're also orbiting the sun. We've got other things that are man-made out there. For example, we've got the International Space Station, which is floating out in space. We've got satellites, which provide things like broadband to us and television signals. We have got space debris. In actual fact, around our own planet, there is an awful lot of space debris from past missions. Okay, it's actually become a bit of a problem because when we launch a shuttle, we'll say, lots of different pieces of that shuttle are lost in space, and they tend to orbit around their planet, creating like a field of debris that we must get through. This can create problems in terms of collisions if it collides with new shuttles we're sending up. So it's something we have to solve eventually. We've got lots of other stuff that we didn't really discuss today, like things like black holes and the different types of stars out there as well. So anything you'd like to find out about that, just check it out on YouTube, check it out, just Google it. There's lots of information out there. Now, how does all these relate to each other? So if we talk about the solar system itself, we said a solar system must contain a star, and it must contain celestial bodies orbiting it. We know the relationships here. We have the moon, okay? The moon is the moon that orbits our own planet, okay? So if you talk about Earth, the relationship here between Earth and the moon is that the moon orbits the Earth. The relationship here between the asteroid belt and the rest of the solar system is that asteroids can collide with other planets. We know that Jupiter, for example, takes an awful lot of collisions of asteroids. We know that meteoroids float around in space, and when they reach our own planet, we call Earth, if they enter our atmosphere, they are referred to now as meteors. We know that we have Kuiper's belt, and we know that we can see comets from our own planet on Earth, usually at night. When we see lights in the night sky, it could be a comet if we see a glowing tail. We know that a meteor is also referred to as a shooting star. That's just a few different relationships there I've discussed so far. The next thing you should know is, well, what else is important, and why study space? So I just talked about one galaxy there, which is the Milky Way galaxy, which contains our solar system. But the Milky Way galaxy also contains about 500 other known solar systems. Imagine that we are only one of about 500 other solar systems. And what's really interesting is that we have now found a solar system which contains 3 planets, we say, which are in the Goldilocks zone. This solar system has been known as TRAPPIST-1 solar system. Okay, sort of a strange name, but TRAPPIST-1 solar system has 3 planets, we say, in the Goldilocks zone. You've all heard of that rhyme, that you've all seen that childhood nursery rhyme, which is Goldilocks. And the Goldilocks likes her porridge just right. So that gives you an idea about why they named these the Goldilocks in the Goldilocks zone. Is because these planets appear to have an atmosphere, suitable temperature, suitable water levels, which means that they could potentially be livable, that we could potentially live on them in the future. So that's why they are interesting. Okay, I'm going to move on now. Right. The next thing then is space. So what is space? So we've all seen these images of like an astronaut floating around in space. And why are they floating? Why like what's affecting them out here in space? So first of all, space is a vacuum. Vacuum here, a vacuum means that there is no air, there's no water, there's no liquid, and there's no gas. So that means there's nothing. That leaves nothing remaining, except for things like forces like gravity and light, which is able to move across by radiation from the sun to our own planet. So this is why a astronaut needs to have a suit when they go out in space, because there's no air to breathe. All of the water in their body is being like their body is being held and hacked by the suit here, which is protecting them from all the harmful things in space like radiation. So space is, when we talk about space, it is nothing. And the reason for that, we believe, is because planets and other celestial bodies have such a strong gravitational pull that they pull all the matter into them to create these spheres. Okay, so all the matter, there's very little matter is left in space. Okay. So that leads on to why should we explore it? And I mean, you probably have your own ideas about this. And obviously, there are dangers to that. Okay. First of all, it's very difficult because the further you get from the planet, the further you get from a planet which is safe for you to land on, where you can breathe the air, where you can get water to drink. But there must be reasons to explore space. Okay, the reasons that we can come up with here are, first of all, the huge developments that have come from space science. Okay, So if you use any of the following, you have used basically science that has come from organizations like NASA and the European Space Agency to solve um, difficult problems in space. Memory foam. Memory foam was designed for space. Okay? Memory foam, we know, is used in shoes, like runners. It's used in mattresses. It's used in loads of different types of furniture. It was designed actually originally for space to solve a problem. Insulation in houses is much better today. Why is it much better? Because we have learned from astronauts. We have learned like space is incredibly hostile, and if radiation gets into your suit or gets into the International Space Agency for or space station, for example, it can um, it can cause like uh, huge problems in terms of it can cause cancer and all these horrible things straight away. You need to be able to insulate against it and protect yourself. So the best insulation that was developed for space science, and then we learned from that and kind of retrofitted it for houses. Robotics. We don't like to send people out on space missions anymore because it's so hostile in space. So the developments, huge developments that have happened in robotics have been have come from studies on the necessity to send out robots to space instead of people. If we didn't have exploration of space, we would not have broadband. Okay, we would not be able to send out a satellite to send a signal down to us. So that'd be one reason there, like just technology, like a branch there. And there's many reasons within technology why it's important to study space science. Other reasons could be, for example, getting new mineral resources. So, like we know on our own planet that we're running out of precious resources like gold and other kind of rare minerals. Okay, so how about if we just looked at a different planet and mined the resources there and took the resources there? Okay, another one would be the possibility of finding new habitable planets. Okay, as I said, in the those three planets mentioned in the Goldilocks zone. How about if the possibility of us being able to live on other planets? Okay, we have a planet Earth at the moment, which is getting bigger and bigger in terms of the population. Will it be able to support us forever? That's the big question. And then there's just new scientific discoveries. I mean, um, all the time we love advancing science and learning more about how the world works around us. So we're making new discoveries all the time, and that would be because space is such like a difficult environment to move across and to live in. Um, you have to come up with solutions to rapid solutions to fix that. So that's why science has moved on so much because of exploration of this really hostile environment. There's obviously hazards though. The main hazards would be like the distance from Earth. Okay, it's very far away if an emergency happens. So for example, if you need to get to a hospital because of some disease, you're not going to be able to do that if you're very far away on a shuttle. You might experience loneliness and isolation. During this COVID crisis, we might know a little bit about that. Um, but imagine if you had to live like that for years on end, and you and just maybe a few other astronauts inside in a shuttle. That would have been that would be very difficult. You'd imagine. Okay. Health, because the International Space Station, for example, has um, you know they call it zero G, as in no gravity. Um, Gravity is really important in maintaining muscles and making sure that our skeleton is stays upright and is strong. But when astronauts come back from space travel, what they often find is that they have to um, they have to strengthen up their muscles and bones again because the low gravity, and when they come back to Earth, which has higher gravity, it means that the gravity starts to crush their skeleton and their muscles when they come back, so they have to build up their strength again. That's why you often see astronauts exercising in space. They have built machines to try to make sure that they don't lose their muscle mass. And finally, the space suits, of course, are there to protect astronauts, okay, and from heat and radiation. Right. So you're going to receive a bit of work from me now, and this is your work. First of all, you are going to look at these notes that I have assigned. Give me 2 seconds now. So I have asked you to take down these notes from 1 until 4 into your notes copy. Okay, you should be as far as this. I'm going to upload the rest of this and ask you to finish off these notes in your notes copy up as far as 6. Okay? You're then going to learn all of those notes and you're going to close your copies. You're going to create a mind map. I'm going to open up 2 assignments on Google Classroom. The first assignment will be to upload photos of your notes. Okay. The second assignment will be to have a mind map drawn here based on all of this. Now, astronomy is going to be a big aspect of your summer exam, so make sure that you have learned it off. Okay, we will talk to you later.